Hello everyone, my name is Nitin Satpute. In this video, I'll be discussing about Llama 3.3 model, which is the latest model, Llama 3.3 from the Hugging Face, how exactly we can deploy this particular model. And then with the help of a Kubernetes cluster, which is OKE cluster on the Oracle Cloud infrastructure. Right now, I'll be discussing about A10 GPUs. So how many GPUs are required and how exactly we are distributing the workload for this particular model. So I will initially give you the brief information, how exactly it is already deployed, and then later on I will give you the commands for further deployment. So let's see my cluster. So already I have my cluster, and I am showing you the number of nodes here. So there are already these many nodes, but out of which only two nodes are important right now because I'm discussing about the A10 GPU. So this particular node and this one, these two nodes are for the A10 GPUs. I have already labeled that. And if we see the pods deployed, so it will be, I do have the namespace which is array. So I do have around 8 pods which I have already deployed. After this, I'll discuss how exactly I'm deploying it. So why do I need 8 pods? There is one ray worker, which is a head node, and the other 7 are the actual worker nodes basically. But the head node is also responsible for computation of the sum of the workloads of the Llama 3.3 model. So now Llama 3.3 model specifically, we are discussing about 70 billion parameter from Hugging Face. It requires around 140, 150 gigabytes of memory. But our A10 GPUs, they have only 24 gigabytes of memory. So in total, if we need, it will be around 8 GPUs. So for example, if you divide 150 by 24, it will be around 6. But in practice, we need certain more amount of memory for activations and some more memory details for further information while computations. So for that, we need more amount of memory. And also, when we deploy it, the Llama model asks for multiple or some number which is dividing the 170. I mean, which is in multiple of 4 or 8 or something like that. So that's why we have to provide 8 number of GPUs. I mean, first constraint is basically the memory, and another constraint is basically it should be multiple of 4 or 8. Otherwise, you will get an error. So for this, I mean, I do have already a deployment as I have mentioned. So which is for that I have created a screen, and that particular screen is provided somewhere here. Let's see. So here the model is already deployed on all the 8 nodes. And then I just want to show you how exactly the 8 nodes are being utilized. So for that, what I need to do, I just need to check the pod utilization and the ray status. So for that, I just need to execute the command. So let's see the number of pods first, and then after that, in each and every pod, like I will choose one of the pods where Llama model is already deployed. And then if I want to check the ray status here, so what I'll do, I'll simply check, give the ray head. So this is my head node. And then for this particular red head node, if you compare it here, you can see it here. And then for this particular ray head node, I will check the ray status. So in the ray status, you can see 8 of the out of the 8 GPUs are already utilized because it does require 8 GPUs. And then it is a array cluster. But if you want to see the GPU on a single node, which is a red node, so that also I can show it to you. it will be a single GPU per pod. But originally on each and every node, there are 4 GPUs. Okay. Yeah, if you see, there is a 24 gigabytes RAM memory, and then 20 gigabytes of memory is already occupied, and there is only one GPU, because for each and every pod I have assigned one GPU, where one is the head pod, another is 7 are the worker pods. So like this, I have created a configuration. So remember this particular configuration. You can assign one pod as 4 GPUs, but you will face many issues. So it's better to have light-weighted pods. So I hope you understand how exactly, I can show you the worker configuration also. We'll go through it once again. So for that, I'm just checking one of the worker pods. Let's see. And then this is my one of the worker. So if you check the number of pods, which one is it? We can see it, KBM, and this is something you can see it here. So this one we have already chosen. So inside this particular worker pod, we can also check the race status, how many GPUs it is showing. So in total, the race status should show how many? Like 8 GPUs. And then, but on that particular node, what is the number of GPUs? I think we are missing something there. How many GPUs are there already? Only a single GPU. So for each and every pod, there is a single GPU with around 24 gigabytes of memory, out of which 20 or 21 gigabytes of memory is already occupied. So like that, we have created a configuration. And suppose, we want to run it. So for that, we need to create some services as a load balancer services. Without that, we will not be able to run the whole model. So I have already deployed those services also, and then I'll be showing you these particular services. So let's check that. So don't worry about the dashboard service. So this is the important service. So Red Hat service basically creating a cluster, which is creating a array cluster along with the worker node. So what happens? The worker nodes try to see a head service. If they don't see this head service, they will not be able to form a cluster out of it. So for that, we need this particular service. Red Hat service for load balancer. So this is creating a load balancer service, which is required for final endpoint. So one way is I have already created this load balancer, and we can forward it also. So with the help of this particular load balancer, and my expose port is 8009. I'll show you the command to run this particular inference. So that's my inference, and then this is because I have not given the proper model name. So you have to provide the proper model name, and then I'm changing it somewhere here. So this is my Llama 3.3 model, which I have saved it locally. So for that, again, I have created the persistent volume claim, and then I just provided the 10 tokens. So that's why it is creating only one particular sentence, very small sentence. But what if I provide 100 tokens instead of 10? And then we can also see how exactly the deployment is performing. So we can go to the deployment. You can see it has OK for the previous deployment, but here it received the request. So received request, you can see it here, and then it is performing some computations. It is on the A10 GPU, so that's why it is slow, and on the cluster of 2 nodes. So now the computations is already performed, and then you can see there the output is already ready here. So there are several popular quantization techniques for large language models, post-training quantization, and then PTQ description, and then there is a quantization over training. So it gives the description for this particular question. So like this, we have already deployed the Llama 3.3 70 billion instruct model. Now, let's delete the deployment, and then I will show you the step by step how exactly different things are working on this particular deployment for Llama 3.3 70 billion parameters. So first of all, what we have to do, I will delete this 2 particular deployments, and then we can start it once again. So let's start it. Let me delete, and then for that, let me show you. There are pods already. Okay, 8 pods. I'll delete this deployment, array head and array worker. Get pods minus and again. Let's see if they're deleting it or not. So you can see they all are terminating now. And then again, after some time, they all will be released. Let's wait for some time. So now I will try to show you a file and then also how exactly different configurations are done on that particular file. So we will start with the array head, and then I have already applied the array head service. So for that, as I mentioned, we need to check. Yeah, this is done. So head service. This is my head service file where I'm giving the app name, the head point name, and then the ports where they are contacting with each other. The dashboard also, and this one also. So what will happen here? Again, I will go back. I'll simply apply. It will do nothing because I have already deployed it. If you see get services, you can see all these services already deployed. This is important, as I mentioned. If I don't deploy it, it will be a problem. This is the array head service. This is the dashboard service. I mean, you can have it, and then also, or in order to check how many GPUs or how the resources are being utilized, for that you can have it. So this array head service is already running, and as I mentioned, this is important in order to connect worker nodes with the head node. So, and this is a load balancer which is required in order to execute the command on the final endpoint, which is provided here by the external IP, because we are dealing on the cluster level Kubernetes cluster from the OKE. So that's why it is important. So I'll simply run my head command first. I'll simply clear it. Let's run the head command, which is given here, and then you can see, okay, this is already running. Let's see how exactly this is my new pod, and then if you want to describe this particular pod, we can check it here. Yeah, the started container array head, and how exactly this file looks like. Okay, so there is a name array head, which is also a deployment name, and then you have created only a one replica, which is a head replica, and then inside the head replica, I'm choosing A10. I have already labeled each and every GPU from A10 as A10. I mean, each and every node belonging to A10 as A10, and then I'm running this particular command for the port and this dashboard port. You can change it the way you want, and I'm allocating only a one GPU for this particular head node. And remember, you need to mount these points. I mean, mount the shared directory in order to see the Llama 70 billion model. I have already stored it from the Hugging Face. For that, you need to perform some. You need to create a request like this, so that you will be granted the request to this particular model. And in order to download this particular model, you have a command from Hugging Face CLI, which is this. So I have already created a PVC. And then those PVCs are also running behind the scene. And then for that, I mean, if you want to see the PVCs, we can see it here. This particular PVC, which is already running. In my previous videos, I have already shown how exactly the PVC is being created. For now, I will simply say, I mean, you need to create a PVC in order to load a shared file system where your model is already deployed, and then you are loading it into the inside the container with the help of a pods inside each and every pod. Now our head node is created, but I want to show you what is the race status at this particular state. You can see only one GPU is being assigned. So let's start with the worker deployment again. So this is my worker deployment. I'll show you the worker file also. So array worker is created, and then let's see. We have worker description also, but let's see the pods. They all are running. I have already done the previous deployment, so that's why they are catching it from the previous deployment, the container image. So it's not taking much time, but let's see again our head node, how many GPUs are being shown for the race status. So you can see all 8 GPUs are utilized. So this can be seen again with the help of a worker pod also. So it has become a cluster of 8 GPUs. So like this, we have already deployed, and then the services are already running for load balance and everything. What we will do now, we will try to go inside one particular node, which is the head node, and then try to execute. But for that, before that, I want to show you where exactly the shared mounting point is loaded. So it's loaded somewhere here. So I have already downloaded 3 models, which is Llama 3.3, 3.1, and 3.1, 8 billion parameters. So that's important in order to deploy the model. So inside this particular node, I will try to use vLLM serve command, which will help me to deploy this particular model and create the endpoint. Remember, for this particular model, transformer version 4.45 is required. Otherwise, you will face an issue for the Llama 3.3 model. I'm giving maximum model length because of the GPU memory requirement. Otherwise, we will not be able to deploy the model on this particular memory constraint environment. So that's why I'm providing tensor parallel size at head. Let's see. Let's wait for some time until it runs. So yeah, there is some problem happening. The number of required GPU exceeds the total number of this. So let's see the race status again. So it shows 7 GPU. So sometimes it happens, it loses one of the GPUs. So for that, we need to check what is happening. So again, I'm showing you the same race status. I didn't modify a lot of things, just like I'm redeploying it with 8 GPUs. And let's again go back inside the container. Okay, we are inside the container, and then inside the shared directory, and let's see, the model is already there. And we are losing the connection again. So this is something, a drawback. We need to figure it out, why exactly it is happening the way it is happening. So here we are, race status, which is 8 GPUs. So now I'm running 3.370 billion parameters with tensor parallel size 8. Let's see how exactly it is running or not. So it is already connected to array. So you can see there is a did not match any variant untagged. So this error is basically because the transform version is outdated. So I need to check this one. So for that, we need to install the required transform version on the head node. And then this will be gone. So it needs 4.45. I need to check the race status again. It is still intact. And then let's run it again. So this will take some time in order to load the model. So this is v0.6.1 vLLM model. You can use the latest one also. This was the stable version I was using previously, so that's why. And this is the model I have saved locally in the shared file system, and then from that I have loaded as a PVC, persistent volume claim. So I'll simply pause this here until the model is loaded and ready for receiving the request. Here you can see the model is already deployed and the UVCon is running at this particular localhost and 8009 port. If I can scroll it up, it takes some time to deploy the model. So what I will do, I will try to provide the request here. Okay, I did it here. And then simultaneously I have to do it here, which was already done. But before that, I need to show you the load balancer file. So these are my services which are already running, Red service and Red. I already deleted the previous and redeployed the new deployment. I mean redeployed the services and the head and worker nodes, worker pods basically. So head service LB, which is running on this particular 152.70.42.13. Head service, as I mentioned, it is basically utilized for cluster creation with the worker nodes. So what I can do, I can try to give this particular information and the IP. And then let's see whether it is. There is a model, again the same, you have to provide the proper model name, which is Llama-3.3-70B. it is not the 3.1 because we have deployed the 3.3. So let's provide the proper model name. Now it is running and let's see, did it receive the request? So initially it didn't find because we have provided incorrect model, and now it has received the request and then it is processing the information. So let's see until the OK is received. OK is received means everything is done there. We can receive the response there. The final response is already received. Yeah, the OK is there. Let's go back to another screen. So you can see the details from the endpoint is already obtained by from the LLM. So yeah, this is it. This is the vLLM deployment with the help of a Ray cluster, where we have created the cluster out of the 8 GPUs. 1 is head node, 7 are the worker nodes, and then we have deployed the Llama, the recent 3.3 model from the Hugging Face on the cluster of A10 GPUs on the OCI infrastructure with the help of a OKE, which is Oracle Kubernetes Engine. So thank you very much.